All right, if you can please take your seats, we are going to get started now with updates from our Rust working group and also our CI working group. So first up, I'm going to introduce Scott Wilson from our Rust working group.
Okay. All right. Hi, I'm Scott. I'm the chair of the Rust working group at the Academy of Software Foundation. Roughly last year, we kind of started the working group because, you know, a bunch of us was kind of looking at Rust as like, oh, this looks like a cool language, and you know, why not, you know, start to try to get it integrated into our studios. Hold on, I'm pressing the right button. There we are. So just very quickly, I also want to try to go as quickly as I can just to leave room for Q&A. But what is Rust? So it's a programming language that's you know, designed to be safe, fast, and concurrent. And you know, usually people say, you know, pick, you know, safe, fast, or concurrent, like, you know, pick two. Whereas with Rust, it's like, yeah, pick all three. It's compiled like C++, strongly typed, and also just adding to that, it's borrows a lot from functional programming, and like the whole entire type system is like very rich and powerful and can do a lot of really cool things. Also, you could say it doesn't really have a runtime, kind of like one scale with like C or C++. So it doesn't really have like garbage collectors like you'd expect, like say Go or Python or anything like that. It's also compatible with C and Python, just kind of built in with the foreign function interface stuff. Like you can basically write this to be like acts like a C API, but also there's some libraries that gives it really good Python support. And just quickly, so the next few slides is just kind of like, why would you choose Rust over, say, Python or C++, and also the other way too, just to, you know, be totally fair. So one of the great things about Rust is, or actually one of the, you know, possibly problematic things with Python is usually most of the issues you're going to run into, you'll have run into at runtime. There's very few kind of, you know, build time errors. Whereas the nice thing with Rust is it allows for building systems where a lot of errors that would be, you know, caught at runtime in other languages, you can have it done at compile time. Also, Rust is generally faster than Python, and it's like about the same speed as like say C or C++. And also, all the dependencies are, you know, just kind of part of the your Rust binary usually. Like it's all by default statically compiled. So you don't have to kind of deal with like, okay, Python path pointing here, Python path pointing here, you know, which versions of my libraries am I going to deal with and have a headache with. But also at the same time, you know, why would you use Python and not Rust? So, you know, the great thing with Rust is also kind of a not great thing when you start off with, in that it's kind of challenging for beginners to the language. There's stuff like the borrow checker, which is kind of, you can think of as kind of like the teacher teaching you how to build proper software, but a very strict teacher at the same time. Whereas Python is just like, go for it. Usually can prototype faster in Python. So it's, you know, much faster to just like hack away in Python to kind of get something to work. And then usually the workflow is like, you know, get it to work in Python, move it to another language. Also, Python has a much larger ecosystem than Rust. You know, the Python package index has like huge amount of packages, where as the Rust crates, which is what they call libraries, you know, it's growing, but not as big. Also, you know, why would you use Rust and not C++? So one of the great things about Rust is it makes it really hard to get undefined behavior. So stuff like, you know, use after free, or you know, accessing, you know, the 20th item in a 10 item list. You know, in C++, it's, you know, kind of easy to shoot yourself in the foot. Whereas with Rust, like by default, it makes it really hard to shoot yourself in the foot. Also, who here has had problems with CMake and like, just spending a whole day or a week or a year, like building up all the dependencies you need? So yeah, the thing with Rust is like its whole entire packaging system, like for the most part, unless you have like a lot of like C or C++ dependencies as kind of part of your build, like it's literally, bring in your project, make sure that you can connect to the crates.io, hit compile, and it'll just bring everything in, compile it, heavenly chorus, it's all great. Also, partially due to this type system and everything, building concurrent systems in Rust is like, say, a lot easier than C++. Usually with Rust, once you kind of add in your concurrent stuff, and if it compiles, it's going to probably work, except for like, deadlocks and stuff like that. But like, if race conditions and stuff is kind of illegal in the language, I won't compile if it detects one. But also on the flip side, why'd you do C++? Like really all the arguments for, why would you use C++ is kind of like, because we're already using C++. A lot of the core libraries, and especially the core libraries in the Academy Software Foundation, are all in C++. Interoperability between C++ and Rust, adds costs. Like you essentially have to go like C++ to C to Rust. So if you're, making heavy use of templates or anything like that, it's doable, but it's a thing. Also, it's much easier to find C++ developers in Rust, just because, Rust is a newer language. I think 1.0, was released in 2015. But yeah, it also takes time to train developers. Like I've heard stories of like it takes about 3 months for someone to be really up to speed in Rust in order for them to kind of really start going. But once they start going, then they're as fast as any other language, I'd say. So very quickly, our mission is our mission for the Rust working group is to create a foundation for C and Rust bindings for all the C++ libraries we use and love. The idea is like, I guess kind of the Trojan horse of, yeah, everyone wants to use OpenImageIO, OpenEXR and stuff like that. Like, may as well, give them all the stuff they need in order to have all that good stuff. So what are our goals? So we want to collaborate with all the communities within the ASWF, and also, external to the ASWF, like say USD and OpenImageIO. And what we want to do is to kind of create C and Rust bindings for all those libraries. And also we're creating tooling to help build the bindings. We have a tool called CPPMM, or C++-, and it allows us to build those C and Rust bindings. We also want to create a set of conventions and rules to make all the libraries consistent across projects, and to try to strike a balance of like, making the APIs look the same as what they do in kind of the source projects that we're binding, but also at the same time, make the best use of the Rust language to be able to kind of work fast and work efficient and gain all the benefits that Rust gives you. And the other last important thing is we want all these bindings to be easily accessible through the crates.io repository. And so what are our non-goals? We don't want to rewrite everything in Rust. Well, we do, but we don't. So we have no intention to be like, okay, OpenEXR must be written in Rust now. That's, we're not here to do that. If OpenEXR wants to rewrite itself in Rust, we're happy to help. So our current status. So we have someone working on USD, and it's making some really good progress. PTEX also, another person working on it, making some really good progress. So OpenXR, at the beginning, we had some really amazing progress and it kind of stalled out a bit. So we're just kind of trying to regroup and kind of try to get that to a point where we push out the door and give the bindings to the OpenEXR project. So you know, if they want to take it, then they have that. Also going back to CPPMM, it's working, it's doing, you know, exactly what it needs to do. But we also see that, you know, other people who are wanting to create, like say C and Rust bindings could potentially use a tool, and it needs a lot of TLC to make it so it's kind of works in a broader space. And also we have an example project for if anybody, you know, if anybody here wants to, you know, say someone wants to create Rust bindings for Alembic, what we're hoping to do with the example project, like here's kind of a structure that you can start with and have, you know, all the basic things you need in order to do the work. And, you know, we're trying to get the CI stuff passing for CentOS 7, Windows and Mac OS, you know, slowly getting there, but, you know, we'd love to get some help with that. And like very quickly, so, you know, if anybody's interested, like we would, you know, love anyone to join us, like, you know, individuals or companies. If there's any bindings that you really want to see, you know, we'll be happy to work with you to get that to happen. You know, we need CI build experience, especially with Windows and Mac OS. And also, if anybody wants to join us. So the organization link has all the information about how to kind of contact us. We're the Rust channel on the SWF Slack, and yeah. So the next slide is for Q&A, but we're going to postpone Q&A just so the CI working group has a chance to talk. So yeah, that's us.
Okay, my turn. My name is Jean-Francois Panisset. I am part of the VS Technology Committee, and that's how I became involved with SWF. And I lead the CI working group. Next slide, please. So, oh, their animation. Can we cycle through that to? There we go. So I think the CI working group has probably wins in having the least catchy working group name. Continuous integration, the original definition was the practice of merging all developers' working copies to a shared mainline several times a day. Back when I was a developer, you know, developers would go off in their own branches for weeks on end. And then when you tried to merge things together, well, that was a bit painful. Now, in fact, what we're really trying to solve here is cloud native continuous integration. We need an environment which is fully distributed, doesn't live on in any one particular company's environment. We want the fewest persistent resources. Everything should hopefully be on demand and spin up and spin down as required. We would like everything to be as automated as possible. We would want everything to be as efficient as possible so that we make best use of anything that has a cost associated to it is used as, you know, generates as little cost as possible. We need something that is auditable, so it has logs and you can actually figure out what's going on. We want something that's secure. You know, software supply chain vulnerabilities have become much more in the forefront recently, and we don't want, you know, last thing we want is for something evil to be injected into our projects. And as I said, you know, everything should be cost effective, free if possible. Next slide, please. Okay. So that was kind of the original mandate of the CI working group, but really we're kind of interested in a lot more than just what you might strictly call CI. In fact, we're really interested in all aspects of the tool chains and the processes that go into creating ASWF projects. And in particular, that means revision control, continuous integration build environments, the actual tool chains used for these builds, how we test, and so automated testing and test coverage and things like that. And then finally, packaging and distribution. And I think one thing that's particularly important is we're not trying to prescribe how any one project should work. Really, what we're trying to do is first is identify patterns that are used by multiple projects, bring those up to the surface and make it clearer so that new projects who are looking at what are the best practices within the foundation and have an easier way to adopt those. And also trying to go out there and keep track of what's being done out there in both the open source and the commercial world, and figure out, are there new tools or new practices that would be worth bringing in? So it's definitely, we're trying to identify a consensus approach and not prescribe. Next, please. So for specifically revision control, the tooling is very familiar. I think it's probably not it's not controversial to say that Git is the predominant system for managing distributed revision control. And we've, the foundation has settled on using GitHub for hosting its projects. And one advantage there is that GitHub probably has a very large mind share. A lot of people are already familiar with it. So it's kind of one less obstacle to onboarding new contributors. There is a Academy Software Foundation GitHub organization. And one of the first steps that when a project is onboarded to the foundation will be transitioning from its own organization. So whether it had a standalone organization or it was within a company's organization, and to transition that into the ASWF GitHub organization. Branching, pull requests, review policies, none of those are specified or mandated, but there is a requirement in order to meet certain levels of ASWF project to at least have those documented. And one of the things that we would like to see is some consistency. But again, that doesn't, if a project has specific needs and wants to do things differently, as long as they have a process, then that's perfectly fine. A couple of details is every project in ASWF should be using the SPDX header manifest, which basically puts an explicit license tag in the in a header comment, and that allows basically reasoning and tooling about licenses, because one of the things that is important in the open source under the foundation is to have clarity about licensing and avoid any bad surprises. There is also the Linux Foundation has an infrastructure called EasyCLA, and that allows projects to set up, if they want to, having contributors fill out contributor license agreements before their first commit. And those CLAs can either be individual, if somebody is contributing on an individual basis, or they can be company CLAs. And then once the project has those CLAs on file, afterwards, you can basically forget about it. And it may seem like a small hurdle at first, but then it means that once your company has accepted the CLA for a project, then you don't have to worry about it anymore. You can contribute, secure in the knowledge that you're not doing something wrong. Similar to that, most projects use a DCO, which is the Developer Certificate of Origin. Just means that you sign your commits with your email address. And GitHub recently added tools to support that also in the GUI. It used to only be supported through the Git command line. Then there's, most projects have to deal with dependency management. They may depend on other projects, and there are tools such as Dependabot, which can be used if you want to do automatic dependency updates. And one of the things that's interesting is that before joining ASWF, a certain number of projects used to vendor their dependencies. So they would have a copy of projects in their own source tree, because before there was a good CI system in place, that just made it easier, and it made it easier also for people consuming the project. But that's mostly not the case anymore. So the projects are encouraged to not just embed copies of other projects. And then finally, I don't have it here, but the Linux Foundation has the LFX dashboard, which provides a bunch of metrics on contribution and velocity and for the projects. There are some challenges in trying to make those metrics meaningful, but I think it is useful. Those are useful tools, if anything, to go back to the purse holder and say, this is what a company contributing to ASWF is getting in terms of engineering effort for its contribution. Next slide, please. So in terms of the actual CI build environment, initially, most projects before onboarding with the foundation were using a mix of things like Travis, AppFair, Circle CI, different, and often there weren't any good cross-platform solutions, so you might have to use different CIs for Linux versus Windows versus Mac. At some point, we briefly started using Azure Pipelines because that was the first CI system that supported all platforms. But now we've all converged on using GitHub Actions. In particular, it's well integrated with GitHub. It offers GitHub-hosted runners that are for on-demand builds on all three major platforms. Those runners have typically an up-to-date software stack, but they have some significant limitations, which we'll talk about a little bit later. The build configuration is just built on YAML, so it's very easy to work with. And when one of the advantages of projects being under the ASWF GitHub organization is they have access to org-level secrets, for instance, Sonar Cloud keys, Docker Hub keys, or access tokens, so that you don't need to, we don't need to manage these on a per project basis. And the Linux Foundation release engineering team can be used to add, can add additional tokens if a project needs to reference a different external resource, and if that external resource might be useful for more than one project. Next slide, please. So this is an example of the GitHub Actions result. This is, I think, for OpenEXR. And it shows that the build matrix can get quite extensive. You might want to build on different platforms. You might want to build with different compilers. One of the things that's interesting, some projects want to build with top of tree of their dependencies, so that they want to be able to know we're not just building against, I don't know, a specific version of Boost, we also want to see the top of their main branch, so that if there's breaking changes, you want to know it sooner rather than later. Also, each project may have a different schedule of its builds. There may be some builds that get done at integration time, every time a PR is merged, or they may want to do some scheduled builds, like if for something more that takes longer or is more expensive. Next slide, please. So in terms of the tool chain, Scott had a quip about CMake, but it does seem like CMake is kind of the de facto standard for all of the C++ based projects. The VFX reference platform does not specify a CMake version, but we'll talk a little bit later about the ASWF Docker project, and that in a way specifies a de facto CMake version per calendar year. And there's a lot of expertise and examples of CMake lore within our various projects. We also typically make use of the Red Hat Developer Toolset, which gives you access to newer compilers on an older OS. Looking back to Nick's talk, a lot of facilities are still based on CentOS 7, and it's kind of still the implied base for the VFX reference platform. But if you want to be able to compile with C++ 14, you need a newer compiler, and the developer tool set gives you that. In fact, the C++ and Python versions which are the main languages of the platform, of the foundation, are specified on a yearly basis by the VFX platform. But there are other languages as well. Java is used in OpenQ, and of course, there's the Rust effort. And another pattern, which is fairly common, is building inside containers, because with GitHub Actions, with a single line, you can say, build inside this container, and instead of depending on the software that's installed on the GitHub hosted runners, you basically get a full environment that has everything that matches exactly the VFX reference platform. Next. So we're testing. There's a fair amount of variability between projects. C-test is used for some of the C++ projects. I've seen some PyTest using for Python. One thing that's interesting is the CII Silver badge, which is one of the requirements for for certain levels of ASWF projects, requires 80% code coverage for the test suite. Then another requirement is linting or static analysis. A number of tools are used here. For instance, Clang Tidy is used by OpenEXR and Open Shading Language. PyLint as part of PyTest, I've seen that used in in several projects. And then Sonar Cloud is a tool where you run, you build with the Sonar Cloud harness, you run your application, it produces a set of tools and an analysis, and then it gets uploaded to the Sonar Cloud website as a dashboard and for drilling down into results. And there's a SWF organization there, and the access token is available to all the projects. And then finally, there is dynamic analysis or fuzzing. OpenEXR being integrated into some operating system platforms is part of the Google OSS Fuzz process. So basically, Google throws fuzzing at a number of important projects. And initially, it was a bit like, I hear it was a bit like drinking from a fire hose. But once the initial set of issues were resolved, it's now become manageable. And it's a very valuable way of finding things that we hard or expensive to find issues that would be hard to deal with otherwise. And in particular, when your project is visible enough that you have CVEs filed against it, those tools are very important. Okay, next slide, please. So this is just an example of the Sonar Cloud UI, and it shows various projects. There are more than that, but and what kind of coverage they're seeing, and so periodically projects go through the Sonar Cloud dashboard and look at useful or interesting issues to address. Next, please. So for packaging and distribution, for Python-based component, uploading to PyPI is typically the way it's done. In particular, OpenTimeline.io has a very well worked out process for building Python wheels as part of its CI. One issue is that currently PyPI does not really have the concept of an organization. So each project basically has to have its own account and manage that separately. But that's on organization level support is on the roadmap. And when that happens, we will make sure that there's an ASWF organization. We have a paid Docker Hub account so that organization projects that upload and want to download from Docker Hub won't be throttled, and or external users, and in particular that's used for the ASWF Docker projects. And there's also a JFrog Artifactory repository, which is starting to be used for Conan packages. And we're also looking at leveraging the Linux Foundation code signing infrastructure as we start producing or more than just source code, but actually binary deliverables. And in fact, a lot of what the CI working group works closely with the Linux Foundation release engineering group, which manages a lot, deploys and manages a lot of this infrastructure. Next slide. So some limitations of GitHub hosted runners is they're typically quite small, x86 only, so there are no ARM or M1 options, there's no GPU. And some projects can't really run their test suites within those constraints, such as OpenVDB, or when they need to build very large packages like the full Clang compiler suite or Qt, you actually time out. So there is the option of self-hosting full-time builders, but that's really tricky. And we've experimented with trying to do the, spinning up and spinning down VMs on demand, but it's really hard to do it. And so we're using AWS Code Build for GPU accelerated builds. And we're also looking at that for bigger requirements like OpenVDB. Okay, next, I'm going to skip this one, just saying that we do have a macOS system that could be used, and that's in progress. Talking about ASWF Docker, so that's, I've kind of talked about, sorry, next slide. So that's our project for providing Visual Effects reference platform compliant containers. It's been quite successful. Apparently, we had above 600,000 downloads pulls of these containers. Next slide, please. And next slide. Sorry, I have to go pretty quickly. Some of the stuff that's happening is we're starting to write Conan recipes so that Conan packages will be available. And that in particular will be probably more interesting for Windows and Mac OS, where, well, there is no, you can't containerize Mac OS and Windows containers have issues. And then, of course, the next big thing is VFX Platform 2023 support And that, of course, ties into Nick's presentation. So we're going to be we're going to start having that soon, and obviously moving the baseline from CentOS 7.9. Next. So that's it. Come join us monthly meeting. The next one is on August 17th. It's at 1 to 2 on Wednesdays, staggered from the TAC. There's the WGCI channel on the Slack, and lots of opportunities to contribute. And in particular, anybody interested in writing Conan package definitions, we could really use the help. Thank you very much. Are there any questions or comments? For either me or Scott, by the way.
So I'm a Rust enthusiast, but I'm kind of finding the problem of GUI, GUI library particularly difficult on Rust, because I didn't really find anything remotely similar to Qt at the moment. And so what are your plans, or do you have any plans of for the desktop UI space for Rust?
Like, I don't think that we have a plan specifically. Like the main goal for the Rust working group is to just kind of, you know, build the bindings for that. So we haven't really, you know, said, you know, this is kind of the other infrastructure that you need in order to kind of build a package. But yeah, I do know that, you know, writing GUIs inside of Rust is still very, it's still very early days.
Brett, thank you.